Okay, welcome back, students. Let's get into section 2.3, differential equations and linear algebra. Okay. Okay, section 2.3 is on systems of linear equations. So let's take an example of a system of equations. We'll do a 3 by 3. 3 equations, 3 unknowns. System of equations. Okay, so if I have 6x1 plus 0x2 is 2x3 equals -2, and x1 minus 7x2 plus 9x3 equals -9, and 5x1 minus 3x2 plus x3 is equal to -1. Okay, this system of equations involving the variable x1, x2, and x3, we could solve it different ways. We could use substitution. We could use elimination. We could start eliminating variables and then back substitute. We could use Cramer's rule. There's a bunch of algebraic methods to solve this. Let's represent this, however, as a matrix. Okay, this system of equations can be represented two different ways as a matrix. The first way is called an augmented matrix. Okay, or we call that A with a little number symbol, or pound, or hashtag, or what, it has multiple names. But in math, we just call it a number symbol. The augmented matrix, A number, okay, it looks like this. I have my coefficient portion, which is 6, 0, -2, 1, 7, -7, 9, 5, -3, and 1. And then I have a little line here. That's just an auxiliary line. It really doesn't do anything mathematically. It's just a barrier put in so that it separates the coefficient part from the constant part. Okay. And that constant part is -2, -9, -1. So this is all one matrix. This is a 3 by 4 matrix, but it's just augmented to have this little vertical bar between the coefficients and the constants. Okay. The other way that we can represent our matrix, our system of equations as a matrix, we could take the coefficient matrix 6, 0, -2, 1, -7, 9, 5, -3, 1, and we could multiply that by a column of variables that we would be working with. Okay, x1, x2, x3. Now that makes matrix multiplication works because this is a 3 by 3 times a 3 by 1. Okay, and if I were to multiply this together, the 3's do match, the 3 columns in the first matrix and the 3 rows in the second matrix. So that will work to multiply. And then that will equal a 3 by 1 resulting matrix of my constants. So this is -2, -9, -1. Okay, so we call this guy, we call this guy here the coefficient matrix. We call this guy the variable matrix. And we call the last one set on the right side of the equal sign as the constant matrix. Okay, they have symbols. A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. And since these are column 3 vectors, okay, I can write them as vectors. Okay. So we would say that A times the X vector, the coefficient matrix times the X vector is equal to the B vector. Okay. Okay, where the X vector, it is called the vector of the unknowns. The B vector is called the right-hand side vector. Okay. If the right-hand side vector B is equal to the 0 vector, which is just a vector that includes zeros. Okay, it's an n vector, n column vector that is just full of zeros. Okay, if write it like this, if B is equal to the 0 vector, this is 0 vector. Okay, then the system is called homogeneous. Called homogeneous. Okay. That's important. That's going to come up a lot later on. Okay, so let's look at an example here. We want to verify that x of t is equal to, okay, that, yeah, verify that x of t equal to 4e to the negative 2t plus 2 sine t, 3e to the negative 2t minus cosine t okay, is a solution to the differential equation x prime equals ax plus b, okay, where A is equal to 1, -4, -3, 2. And B, our B vector here, okay, and B is equal to -2 times cosine t plus sine t, and then 7 sine t plus 2 cosine t. Okay. Okay. So we need to find out, well, we know what x is. X is going to be our variable matrix. Okay. Which is x of t. Okay, that we're given. And so B we're given, A we're given. The only thing we don't have for our equation here is x prime of t. So we're gonna look at this and we're gonna get x prime of t. So let's take the derivative of each entry. Okay, so this is not a 2 by 2 matrix. This is a 2 by 1 matrix because there's really only one entry. There's an entry on the top and an entry on the bottom. Okay, so keep in mind that is a 2 by 1 matrix. So we're going to take the derivative of the top and then the derivative of the bottom. Okay, so x prime of t is going to be 4e to the -2t. Well, that's just going to be, derivative of that is 4 -2 e to the -2t plus 2 sine of t. The derivative of 2 sine of t is 2 cosine t. Okay. And then the derivative of the bottom here, that's 3 times -2e to the -2t minus the derivative of cosine is negative sine. So this is going to be a negative sine t. So the derivative ends up being 8, right? Because these are being multiplied. -8 e to the -2t plus 2 plus 2 cosine t, and then -6 e to the -2t plus sine t. So that's x prime, and I want to see if that's going to be equal to a times x plus b. Okay. So let's plug it in. Okay. Let's take this. Okay. Is x prime of t equal to a times x of t plus b? Okay. So we're going to do -8 e to the -2t plus 2 cosine t, -6 e to the -2t plus sine t, and I want to know, is that going to be equal to a, which is 1 -4 -3 2 times x? Well, what was x? X was this guy up here. That was 4 e to the -2t. 4 e to the -2t plus 2 sine t. Okay, and then 3 e to the -2t minus cosine t. And then I want to add to that my b, my two column vector, column two vector, I should say. Okay, and so that's going to be -2 cosine t plus sine t, and this is 7 sine t plus 2 cosine t. Okay, so what I want to do is I want to multiply this 2 by 2 matrix by this 2 by 1 matrix and get a 2 by 1, and then add that to this 2 by 1 matrix. Okay, so let's multiply through. Okay, we're going to multiply the first row times the first or the only column here. Okay, so what I get is I get 1 times 4 e to the negative 2t plus 2 sine t minus 4 times, okay, or plus -4, it really doesn't matter. I'll do a plus -4 if you makes it easier to see. Okay, times 3 e to the negative 2t minus cosine t. Okay. That's the first entry. And then we're just going to add to that this guy here. I might just save myself the copying and see if I can grab it and then duplicate it. I don't know if I can. I should be able to. Okay, that didn't really work the way I wanted it to. Okay, let's just rewrite it. Okay, so plus, okay, let's do now second row times column. Okay, and so we get -3 times 4 e to the negative 2t plus 2 sine t. And then 2 plus 2 times 3 e to the negative 2t minus cosine t. Okay, and then we're going to add on to that our b, -2. Let me distribute this -2. -2 cosine t plus -2 sine t, and then 7 sine t plus 2 cosine t. Okay. So let's distribute or multiply it by through the coefficients or the constants here and try to clean these things up. So multiplying through by 1, I just get 4 e to the negative 2t plus 2 sine t. Multiplying through by -4, I get minus 12 e to the negative 2t. Minus that's a plus 4 cosine t. Okay, and then -3 times 4, that's -12 e to the negative 2t minus 6 sine t plus 6 e to the negative 2t minus 2 cosine t. Okay, plus this guy here, -2 cosine t minus 2 sine t. And this is 7 sine t plus 2 cosine t. Okay, so what does this become? Let's combine some like terms here. Okay, let's combine these and we'll combine these. This equals -8 okay, -8 to the -2t plus 2 sine t plus 4 cosine t, and then -6 e to the okay, -6 e to the -2t minus 6 sine t minus 2 cosine t. Okay, so now I want to add to that -2 cosine t minus 2 sine t and 7 sine t plus 2 cosine t. Okay, so when I add, I'm just going to add the first entry times in the first matrix times the first entry in the second matrix. So I can just rewrite it like this. It's -8 -2t plus 2 sine t plus 4 cosine t minus 2 cosine t minus 2 sine t. Okay, and a -6 e to the -2t minus 6 sine t minus 2 cosine t plus 7 sine t plus 2 cosine t. And so, oops. And so the cosine t's cancel out there, the sine t's cancel out there. I'm left with -8 e to the -2t. Okay. And then plus 2 cosine t, because the 4 cosine t minus the 2 cosine t is 4 cosine t. I'm sorry, 2 cosine t plus 2 cosine t. And then I am left with -6 e to the -2t. And then the 7 sine t and the -6, that's just 1 sine t. Okay, and we're saying that that was equal to, okay, x prime of t. And was it? Well, what do we get up here? Up here, 2. We have this guy here that we already solved. Although, did we solve it correctly? Oh, I'm missing a negative there, sorry. Okay, and so, yeah, so it's -8 e to the -2t, 2 cosine t, that does equal, okay, with -6 e to the -t plus sine t on the bottom, that does equal what we got down here. So if you could see the whole thing, you can see that it does work. Okay. That x prime of t, okay, x prime of t is equal to x prime 1 over x prime 2. Okay, is -8 e to the -2t plus 2 cosine t, -6 e to the -2t plus sine t, and again, that's exactly what we get down here as well. So it does check. Okay, so this does equal x prime of t for this certain A matrix, and for our X matrix, our variable matrix, and our constant or right side matrix, right hand matrix, I should say. Okay, so that does check. Okay, and that's 2.3.